Welcome back once again to the MongoDB Podcast Live. My name is Michael Lin, and I'm a developer advocate at MongoDB. We've got a great episode lined up for you today. We're going to dive into the world of artificial intelligence once again with a great partner of MongoDB. The company is Together.ai, and we're going to talk about the partnership and the tools and the capabilities that Together and MongoDB bring to you. I want to thank you for joining me today. I'd love to know where you're joining from. I always like to start live streams that way. Find out where folks are joining the stream from. Where in the world are you? Let us know that. And let us know what your interest in artificial intelligence is. Are you building apps? What large language models are you using? How are you deploying these? How are you fine-tuning those models? That's something that we're going to talk about with Together AI. So we've got folks piling in. Welcome to the stream. All right. Without further ado, let's get started. I'm going to bring my guests on stage. We've got Heejin Zhang and Hassan El-Magari from Together AI. Thanks so much for joining me today. Welcome to the show.
Thanks for having us.
Thanks for having us.
Yeah, welcome. So we'll start with Heejin. Introduce yourself. Let folks know who you are and what you do at Together.
Sure. Hi, everyone. My name is Heejin. I'm a product manager at Together AI. These days, I largely focus on product and project related to fine-tuning and training. I also work on the launch of embeddings endpoint, which actually one of the important parts of the launch was the partnership with MongoDB. So it's really excited to join this podcast today.
Yeah, welcome. And Hassan?
Yeah, my name's Hassan, based in the East Coast in New York. Similar to you, Michael, I do developer relations at Together. So a lot of content and example apps and going to conferences and hackathons. It's a fun time.
Yeah, fantastic. It's a really exciting time for artificial intelligence. And I think a lot of people are in the prototype phase. Folks are developing apps and prototype training large language models with specific data for their industries and for their businesses. Where does Together come in? Heejin, do you want to give us an explanation of what Together AI is and what the mission is?
Yeah, sure. So Together AI provides a cloud platform for open source and independently developed AI systems. Our mission is to advance open source AI and make them widely available for building models by ourselves, and also providing a platform to others to do the same. To achieve these missions, one of the key part is optimization. So we are building the industry's fastest and most efficient platform for training, fine-tuning, and serving these generative AI models by focusing a lot on the optimizations at all levels of the stack. So we also provide this kind of solutions to enterprises as well. So bringing this stack to any environments they want, including like Together Cloud or private cloud or on-prem as well.
Yeah. So it's really in the infrastructure space that Together surfaces to the developer. I think a lot of folks are familiar with leveraging off-the-shelf large language models. It's really when you want to fine-tune or create your own large language model that Together comes to play. Is that correct?
Actually, both. So we host more than 100 plus open source models, including chat model, language models, and image models as well. So if you can find this powerful open source models working out of the box for your applications, you can just use it. And one of the really strengths of our inference API is really fast and efficient, and it can be very affordable. So you can use it right away. And on other parts that if you have a very specific use cases, or if the model is too big and if you want to specialize it with a smaller model, you can do that also as well with our fine-tuning API. And then after the model is fine-tuned, you can directly use that to using our inference API. So wherever you are in your journey, we want to support you.
Yeah, I love the platform approach. And something that is kind of, I don't know, not confusing, but it's something that folks might trip over is MongoDB is an operational database. It's a general purpose database that you can use to store your operational data, your transactional data. It's got time series. It's got Atlas stream processing. There's so many capabilities in the database itself. It's become a fairly large and capable platform. But if you want to leverage AI, if you want to build an AI application, you need to encode you need to create embeddings for your data, and it makes sense to store those in MongoDB as well. So the natural step is then, well, how are you going to get that data encoded and the embeddings created so that vector search can work for you? And that's where Together.ai comes in. Hassan, talk a little bit about the API that you offer and how that's leveraged by developers today.
Yeah, absolutely. Like Heejin said, I feel like there's kind of two paths of the platforms. There's the self-serve, go to Together.ai, sign up, get an API key, and just start querying our API. And you can query all of these open source models and like Llama 3 with chat models and Fusion and everything else. And as part of that API offering, we have embeddings. And with embeddings, you basically can send in a string or an array of strings, and you send it into our embeddings API, and it outputs vectors. And like you said, Michael, very, very useful for building these sort of RAG applications where you want to encode a lot of context. Say you have a PDF with 5,000 pages, and you want to, try to use context from that PDF. The ideal thing would be to just pass it into an LLM, ideally, and ask it like, hey, here's the 5,000 page PDF. Can you give me an answer? Unfortunately, LLMs have context limits, and you can't really do that. And so that's where embeddings come in. You can take that, you can break it down to chunks, you can embed it to get the vectors, and then you can use MongoDB to actually store those vectors and keep them there so that a user can ask questions, and you can run like a similarity search through MongoDB Atlas and look up the most relevant vectors to use. So I think the two platforms work together really nicely.
Yeah. So there is a partnership. We formed a partnership. We're working together. What does that look like, Heejin?
Yeah, so MongoDB was a crucial partner with the embeddings endpoint launch. The part of the biggest motivation of embeddings endpoint launch is that there are many different ways to make an LLM application. So we have the inference API, we have the fine-tuning API, and we have the GPU cluster and custom models. But RAG is like a very important part of part of the building LLM application, and embedding model is a crucial and essential part of the building RAG app, including and also generation app. But the RAG also includes a lot of many different parts, not just embedding model and generation model, but vector database, vector search, and different platform. So we basically with this launch, we wanted to enable users to build the RAG applications without worrying about where do I find the different tools, what is the best way to utilize this, and things like that. So kind of really MongoDB provides a complement and it complements the Together's endpoint launch and APIs as well. So it kind of completes the embeddings launch and providing a for RAG.
Yeah, so providing that repository to store the embeddings as well as a vector search engine, basically, to enable you to query effectively, leveraging those embeddings. So if you're just joining the stream, we're talking about Together.ai and the capabilities of the platform, the partnership with MongoDB, and we're going to get to take a peek at it very shortly. But maybe some background on how Together came to be. How did the idea for Together come to be? Maybe Heejin.
Yeah. So our founders and founding members, many of them are serial entrepreneurs or the leading researchers. So they've been clearly seeing the importance of AI for the recent year, especially. And one of the biggest challenges of these days, this large generative AI model, is the distributed training and distributed serving. And the optimization is a very key part to make this training to fine tuning and serving possible to in a production scale and efficiency and affordable price. And our research and a lot of work that our founding members and founders did is including flash attention to and many other innovations behind. So I think that's a natural motivations to build this platform and also around the open source, because we really believe the open source is the future of AI and make this very diverse type of model possible with the transparency, accessibility to many developers.
Yeah, thank you for that. So when it comes to developers leveraging the platform, what is a typical use case? How do developers interact with Together today? I mean, I know we have an API, but is there a user interface or a SaaS offering that Together has?
Yeah, Hassan, do you want to go ahead? Hassan is
Sure. Sure, I can talk about that. Yeah, so a really easy way that people interact with the platform is they just sign up to Together.ai, they get their API key, they get a playground, which is cool. So they can play around with all sorts of models. They can test out different LLMs for chat models like Llama 3 and DBRX and Qwen 1.5. There's like, it's such an exciting world in AI where you get a new model that comes out every week and it's better than the old one. And it's pretty amazing. And I think we pride ourselves on partnering with a lot of these companies as well. So we can do a lot of the time same day offering through our API when a big model is released. Like when Llama 3 was released, it was in our API kind of the same day. But yeah, we offer a playground where people can kind of query a lot of these chat models, where they can query image models as well and query language models and generate code with like Code Llama or all of our other code models. There's just a lot to choose from and a lot to experiment with. So we get this playground that people can kind of query really easily, and then they can just start hitting our API to query any of these models to and to run embeddings, to run fine-tuning jobs. I think like a typical user journey is like maybe somebody goes to the playground, starts playing around with models, chooses the model that they want, and then starts querying it through their API. And we offer, kind of pricing as you go. So you sign up, you get some free credits to experiment with, and you kind of pay as you go. We do pricing per token, and then eventually you might want to fine tune a model, and so you can kind of very easily transition into that and fine tune a model on our platform, and then kind of run inference through it and add it to your application. And then for like kind of more serious, I guess teams, you can also kind of rent GPU clusters and pre-train models yourself, or do kind of whatever you want on them.
I'm gonna expose my ignorance. When you fine tune a model, what's actually happening? What are you modifying the LLM and like creating a bespoke copy of that? Like what happens when you fine tune a model? It's beyond RAG, right? It's beyond training it with data. Can you help me with that?
I can help you with that. So for fine tuning, you can essentially think of like the name fine tuning is coming from that you really tune a little bit of the weight to make this model working as you desired. So the fine tuning is essentially changing the weight directly of the model. There are many different ways of fine tuning. So for example, there is like a fine tuning, parameter efficient fine tuning, which sometimes you actually only change a little bit of the weight. So you don't have to do full fine tuning, but in general, fine tuning is to directly control the weight as you go. So for fine tuning, you grab a base model, and then you copy of them, of course, and you copy let's say if you fine tune the open source model, Llama 3, 8 billion parameter model, you have a copy of model, and you started to train this model and updates the model weight directly. But a lot of times fine tuning, because fine tuning is starting from pretty good base model, you don't want this model to behave too differently than the base model. So your learning rate is usually pretty small, and you want to adapt to your new data, but not really losing the original capability. So there's many different ways to make this fine tuning work really well, and that kind of depends on the base model capability and also the difference between your base model and also your custom data. So something that I think the community is keep trying to find the better recipe and as a whole.
Yeah. So I fine tune this model, and perhaps I'm doing that through a series of questions and answers, and finding out how the LLM is responding to my specific queries given my data. And then I've got this separate copy, and I need to host it somewhere, and that's where Together.ai helps as well.
Yes. So we on our API, which hopefully we will briefly share later, but you can just fine tune a model with just 2 command line. One is uploading your custom data, and one is to kicking off the fine tuning. After you kick off the fine tuning job, you will be able to see the event logs from our playground, like job page. So there is a log that you can see, and you can also connect with the weights and biases key, so you can see the loss functions, like loss values going down or going up, depending on how well you're training. So after the job is done, you can actually just click one button and then deploy the fine-tuned model, and then it will just deploy using that same inference engine that we are using on the back end. So that's like a really, I heard, a very convenient way to fine-tune and also complete the deployment as well. And I want to add one point, that if you ever train a model or host a model by yourself, kind of the configuring GPU is also something that you need to do. So fine tuning, let's say if you fine tune Llama to like 7B model, you need one node, which is 8 GPUs. So you have to configure 8 GPUs. But when you also want to host that for inference time, you don't need that many GPUs. So you only need the 1 GPU. So kind of if you want to do this thing by yourself, you have to configure 8 GPUs or 16 GPUs and then bring it down to 1 or 2, and kind of back and forth is not really time efficient thing to do. So we basically provide a platform for you to just forget about all this part. You just focus on basically like analysis and data science and very task-oriented parts, and forget about all this platform.
Yeah. So the process of scaling and maintaining over the course of the life cycle of developing your fine-tuned LLM can be challenging for sure. I love the breadth and scale that Together offers. I guess we're teasing the audience enough. Hassan, what do you think about showing folks what this thing looks like?
Let's do it.
All right. So you've got your screen shared?
I do.
All right.
Let me know if you all can see it.
Yep, we can see it fine.
We good?
Yep.
Awesome. All right, cool. So I want to talk about the platform, but I want to do it in a way that's hopefully a little bit interesting. So I'm going to talk about this app that I built. It's a full stack RAG app. It uses Together.ai and MongoDB, both. And so I want to just go through the app, how it works, how, I fit MongoDB and Pinecone into this app. MongoDB and Together.ai into this app, and we'll take it from there. So I guess I can start off with a really quick demo. So it's called pdf2chat.com. It's an actual app. I'll go to my analytics. It's been used thankfully by over 20,000 people so far. And the way the app works is it lets you chat with your PDFs. So you can go into the app, you log in, and after you log in, you get this dashboard, and this is a dashboard of PDFs that I previously uploaded. You can come here and upload one. And what will happen actually when you upload a PDF is we take that PDF, I use LangChain to read all the text from the PDF and break it into little chunks. And then I send it to the Together API for embeddings. And then I take those embeddings and I store them in MongoDB. So I want to upload a new PDF. I'll just click on one of these PDFs. Was one of my favorite books growing up, Fahrenheit 451. So you can see, you can kind of read the PDF on the left-hand side if you want to, and you can chat with it on the right-hand side. So we can ask who is Montauk, who's a character from the story, and it will actually answer. So it takes this query, it embeds it itself, and then it runs a similarity search. And to find the most relevant, kind of chunks from this PDF, and then it'll actually feed those chunks into the LLM. I'll show some code. I'll show my whole system prompt for how I'm doing this, for how I'm fetching everything from MongoDB as well, and it sends it to the LLM. So all the LLM sees really is it sees answer the user's question, who is Montauk, with this context, and it pastes in paragraphs of context from the PDF. And it even cites the sources. So it uses kind of 4 paragraphs, and it, answer the question. You can even click any of these sources, and we can go to the text where this kind of answer is, which is interesting. So that's kind of the full app. This is the kind of the architecture of the app over here. So a user uploads. A user basically signs in, you get the dashboard, and there's 2 basically endpoints. There's an ingestion endpoint and a chat endpoint. And I'll actually just look at them in the code, because I think it might make sense to just dig into this. So this is the app. It's open source, by the way. You guys can check it out. We can drop a link in the chat as well, github.com/PDF2chat. It's a Next.js app. So the tech stack, I'm using Together AI for inference for the LLM. I'm using Mixtral, but I'm probably going to switch to Llama 3 soon, or run evals. Actually, I'm going to show off my observability stack as well, so we can see like what actually happens when I ask a question. But yeah, I use mixed roll through Together.ai. I use M2BERT ADM for my embedding model. Together.ai also offers, you know, a bunch of different embedding models depending on what kind of data you're doing, depending on what kind of chunking size you're doing. We offer a bunch of that kind of stuff. We have MongoDB set up as the vector database. I use LangChain for kind of parsing a lot of this logic. I use S3 or bytescale for storing the PDF. I use Clerk for user authentication, and then I use Vercel for hosting, and the little Postgres database that I'll actually show off real quick. So if I'm using a tool called Prisma to interact with my database, and so I can actually go to my my PDF to chat repository, and I can run npx Prisma Studio, and it will actually open up a local version of my database, so we can actually take a look. So if we see that, you see I have a table called document, and I have 9,700 documents, which means people have uploaded 9,700 PDFs, and we can actually click into this table and see like all of these different file names. You see people are uploading stuff about SaaS companies and object-oriented programming, and
hey, that's
like
mine.
Random.
No.
Is it?
No.
Yeah, just you know, a bunch of cool PDFs. So it's nice that it's very general purpose, you know, and it has real usage and is scaled very well with Together at Mongo, which is always cool to see. So actually, right before we dig into the code, I want to show off Langsmith real quick. So I use this tool called the Langsmith from the LangChain folks to actually be able to show me traces of like what actually happened. So you'll see here, like also the people using the app are using all sorts of languages, which is cool. I think this is Russian. I see like French in here as well. But this is our query right here, which we just did a couple of minutes ago with who is Montag. And so what's cool is I can click into this and I can see like detailed information on, okay, like this is the input that was sent. This is the output that was actually, you know, displayed in the app, but we can actually dig into stuff and look at what documents it got. So we can click here and we can see the chunks that it's actually taking. So this is an example of a chunk for that specific case. We have these 4 chunks here, and you can see we have some metadata here that I store. And a big reason I store this metadata is because I want this page number, you know, so we can actually display them, you know, because back over here, so we can display these pages down here. So I actually store some metadata, and then I store the actual content. So this is an example of a chunk that I grabbed from MongoDB from my from the vector database. And this is another chunk, and this is another chunk, and this is another chunk. So I grabbed 4 chunks basically, and I pass them in. And you can see like the full prompt is like what gets sent to the LLM is this. It just says who is Montag, and then it passes in the context, and the context is those 4 prompts. So here's 1, 2, 3, 4. So this is all the LLM sees, is it sees the question and the context, and it has like there's a full system prompt as well. Let me see if I can show that over here. So this is actually the full prompt that the LLM gets. So it says, you're a helpful AI assistant. Use the following piece of content to answer the question. If you don't know the answer, say I don't know. You know, we try to prevent hallucinations as much as possible, because that's you know a really, really big problem with LLMs. And then it passes in the context into this little context tag. We've seen that like these XML tags actually work really well with LLMs. So it passes in all that context, and then it says answer your question in Markdown, because I parse Markdown from my front end and I display it on the page, and then it output this stuff. So yeah, anyway, Langsmith is kind of cool. You can kind of visualize this whole process over here. You can also see how much time it took. So it took about 3.5 seconds. If there are slowdowns, you can see, oh, what part of this actually took a long time. You can see the LLM part took about 2.33 seconds. And so maybe the retrieval part took a second. Yeah, so it's kind of just an interesting way to visualize things.
So I love the visibility. Tell me once again, how is this visibility made possible? Is that because of the call through Langsmith?
Exactly. Yes.
Yeah.
So, yeah, I basically added Langsmith to my application. So every single query that I actually do is sent to Langsmith as well. And it's really easy to visualize as well because I'm using LangChain. I think Langsmith works outside of that, but I think it's definitely a pro. And shout out to the LangChain folks. They helped me integrate Langsmith into my app, and I found it very valuable.
Powerful. Yeah.
Yeah.
So what else are we going to see?
Yeah, we can see the total tokens as well, which is actually interesting because a lot of people think about pricing. It's just very, very common.
Sure.
And so when you think, so this total query took about 1,000 tokens. The way tokens are calculated is it's input tokens, which is my whole prompt, plus the output tokens. And you can think of a token as like 3/4 of a word. Obviously, different words get tokenized different ways, but it's about 3/4 of a word. So this entire call, basically, you can even hover over it and see it's mostly in the input tokens, but 1,178 tokens. If I go to Together.ai/pricing and we look at, I'm using Mixtral, which is actually a 35 billion parameter model. So we charge by tokens, like I said, but also by model size. So you have to kind of look at what size your model is. We're using Mixtral 8x7b, so it's 56. Actually, we have special for pricing for that. We have mixture of experts pricing. So it's 60 cents per 1 million tokens. And we just saw 1,000 tokens. So, 1,000 tokens is, 60 cents divided by 1,000. So 0.06 cents. So $0.0006, right? So it was, pretty affordable to run that single query. And even when you get to so 1,000 of these queries, for context, 1,000 of these queries with that pricing would cost 60 cents. So yeah, and that's for the current model. So just for folks that kind of are interested about pricing.
Can you talk a little bit about the metrics that you would use or view to determine the efficacy of the model? Like if I want to begin fine tuning, where do I look?
Yeah, that's an amazing question. So if you want to fine tune, I guess just take a step back really quickly. Heejin, I think, described the process of fine tuning very well, but I'll talk about, I guess, a little more high level on why someone would want to fine tune. So a lot of the time, from what I've seen, there's two main use cases for fine tuning. One is you're using a big model and you want to use a smaller one. And why would you want to use a smaller model? A lot of the time, it's a lot faster. It's a lot cheaper. Even if we got our pricing again, let me show you the difference between a small model and a big model. A small model is like a 7B model. Over here, it's or even a 4B one, 10 cents per million tokens versus a 90 billion parameter model, which is $1.80. You see, there's an 18-time difference between price, which is a lot. Right. So there's, if you're using an LLM with this and you use this data to fine tune it to run on 4B, or 7B or 8B, you get a lot of price increase, but you also get a lot of speed increases as well. A lot of these smaller models are just a lot faster as well. So if latency is something you really, really care about, you might consider fine tuning, and especially if this 8B model can't do what you want to do. Say you have a use case, your LLM, answers complex math problems. You feed it multi-step math problems and you try to get an answer. And that's actually that's an area where LLMs usually aren't amazing, or at least the smaller ones sometimes struggle with that. So maybe you can, the only model that works for you is 110 billion parameter model for actually answering these math questions reliably. Right. But you don't want to use it because it's too expensive, because it takes too long, because your users want to get their data really quickly. So what you can do is you can use this 110 billion parameter model for a while. You can collect data and you can take that data and you can fine tune a 7B model on it. And supposedly you can try to get basically the same accuracy as this model. So obviously really, really great, much cheaper, much faster. That's one kind of use case that I see. Another use case that I see is if just LLMs are not doing what you want in general, this is such a random example, but say you have a vegetable factory, right? And you have all these tomatoes that are coming in every single day. And what you want to do is you want to assess the quality of these tomatoes as they come in. And so say they're just coming down on this conveyor belt or something like that. And what you do is you take a picture of them and you take that picture and you pass it to an image to text API. There's a lot of APIs like that. There's Lava and all these other APIs. And so what you end up with is a description of the image, right? You end up with all these descriptions. And what you want to do is from this description, you want to determine, what percent ripe is it, or what, you know what I mean? And you want to only keep tomatoes that are 80% ripe or something. And if you pass that description to an LLM and you say, hey, what percent ripe is this? Like, it's probably not going to do great. Like, it doesn't know that much from that description, doesn't know what your particular thing is. But you can feed it data. You can feed it a ton of descriptions, and you can actually manually be like, okay, this is 85%, this is 90%, this is 92%. And you can feed in all that information to an LLM and have it learn that, oh, if it sees this stuff in the description, maybe it's this. And so this is like a random example I just made up, not grounded in anything. But like, that's an example of something like that base LLMs might not do an amazing job of, and that you would want to fine tune an LLM to do. So those are the two main use cases. And back to your question on how you would do that. So especially if you're using an observability tool like Langsmith, or if you're storing your data in a database or whatever you're doing, if you have the data, you can actually just go and try to run a fine tuning job. I think the way Langsmith works is you have to create a data set and tag some of your data, and then you can actually run it. This is actually an example of some evaluations that the Langsmith team has helped me run, where I've actually run evaluations on. So I picked a couple of example pieces of data. I got 62 from some of my customers, right? And I added them to this data set. And what I did is I ran this script that compared a bunch of different models. So this isn't fine tuning, but I compared like Mixtral versus Llama 3, and you can actually see like a score of how well each one did, which is actually really interesting. And so you can see like, this shows me that like, oh, like Llama 3 70B is the best model. It performed the best out of any of these with 79%. And the current model I'm using now is this one with 60%. And you can see even an 8B model performed with 62%. So at the very least, I should probably switch to this 8B model. A lot of the time I tell people to kind of, this should be a step one for how to use LLMs, how to experiment with LLMs, is you should try different ones before fine tuning, because fine tuning it's pretty involved. You need to get data in a certain format. You need to collect enough data. You need to, it's like there's a lot of stuff going on there. Whereas evaluating different models is relatively easy. We let you query a model in like 3 lines of code, and you just change the model string and just query a bunch of them. So in this case, it makes a lot of sense to get some of your data and actually run some evaluations and see what model is best for you. And is this giving you the right results? And so you look at these results and you say like, oh, okay, for Llama 3 8B, it's like the score is 62. Am I happy with that score? And if I'm happy with it, amazing. I'm going to stick with that model. If I'm not happy with it, I can switch to a bigger model like Llama 3 70B. You see it did significantly better. But if I'm still not happy with 70B, or I feel like, oh, like I want 70B's performance in 8B, that's when I can think about fine tuning. And that's when I can get this data and put it in the right format and kind of follow our fine tuning guides. We have pretty good docs on that.
Yeah, no, fantastic explanation. What are some of the challenges that folks face as they begin to get from leveraging off-the-shelf open source models to actually beginning that process of fine-tuning?
Yeah, Heejin, you want to take this one? Heejin, for the record, Heejin is the product manager lead for fine-tuning, has worked with a bunch of our customers with that, and so she's kind of very knowledgeable in this area. Whereas I'm out here just talking about random examples and showing you what I'm doing for my specific app, but she'll be able to give pretty great answers.
Great.
No, Hassan is great, like informing all the experience of the developers and things. But Michael, could you repeat the questions again?
Yeah, sure. So I'm wondering, what are some of the challenges that developers face as they begin to make that jump from leveraging an off-the-shelf model to beginning to look at fine-tuning?
Yeah, I think the important part is actually a lot in the data side. And I think for a while in the just like AI community in general, like we tend to, even for like ML researchers and engineers, tend to focus a lot on the model side, model architecture, and modifying model. But we tend to have a lot of headroom in the data. And when you fine tune, that's a really important part. Like that's also part of the benefit of using open source model. Not all open source models publish what kind of data they used, but sometimes they include some extensive information of data, maybe not exact ratio, exact data, but kind of show them like what kind of data set was used to train this model, which is very important. Let's say you want to you want to fine tune on your own code base. You have like pretty big code base you want to fine tune so that the model can just answer based on your code base, which is none of the open source model out there will ever seen that code before. However, if you're picking a model that is like barely trained on the code model, that's going to take a really long time, and you will need a lot of data to fine tune this model to make it available for your use case. So good things to do is to, okay, like let's find out the open source model that is trained well with the code, and then they has a basic code capability because that's aligned with my data. That's kind of the simpler way to looking into what kind of data and how much data that I might need. And you definitely need some iteration of the experiment, but that's one way to do it. If you go into actually deeper into it, you can actually leverage it embeddings as well. So you can kind of sample some of the data set that if you have access, the base model use or similar to what base model use, and then see the similarity between this base training model and also the data set that you have, and kind of measured how similar this data is to your base. And also, as Hassan said, you can also evaluate on your test set and see how well this open source model is and pick which model will be working the best. So a lot on the focusing on the data and also formatting the data set and your data properly so that the base model can learn it faster and efficiently.
Yeah, so a lot of work, but the benefits are clearly in efficiency gains and reduced cost. So I think that's well worth the effort. Do you have any success stories you can talk about? Any customer success stories, or maybe if you even can't name the names, just talk about some of the stories around the success.
Yeah, I can share a couple of them. So I guess not just the fine tuning, but throughout the different stacks of our product. So first we can, the Pika Lab is the text to video generation company. So they used our GPU cluster to train their model. And because our GPU clusters are really optimized for distributed training and they're affordable compared to other solutions out there. So they were about, I think they were able to save about $1 million over 5 months of period. And then they built this really great product. So we are really excited to see their launch after they used our GPU clusters. Yeah, we have a customer success stories right there. Another company that we'd like to share is Upstage. Upstage is the leading LLM company from South Korea. They've been building a lot of great open source and private models, and what they actually use Together.ai for is the inference API and inference serving time. So they are a great model builder, and they wanted to make these models available to many end users, but in a very affordable and also very optimized, scalable, and robust setting. So they come to us using our inference engine, inference stack on the back end to serve their models to other users. One last companies we can also mention is Rogo. So Rogo is the AI platform company for financial services, and they're actually building a lot of RAG type of open book settings of the applications. So because you want to get the factual information, so you want to cite them like, hey, this is information that's coming from to provide some financial information. So one of the important and also interesting part of RAG is that often people think of RAG and fine tuning as two different ways of building LLM applications, but you can actually do both at the same time. So you can fine tune embedding model, you can fine tune generation model for your own use case, and then build a RAG on top of it. So Rogo is like a very interesting use cases where they fine-tuned some of the open source models like Mixtral on our platform with the finance data using their indexing technology they have, and they were able to show that this performs much better than like really large closed source models out there. So we are so excited to see those kind of examples and love to see more coming.
Yeah, I love that. So, I mean, am I correct in assuming that like the perfect model wouldn't really require RAG, right? I mean, the perfect model would be trained so efficiently with your specific data that you wouldn't have to apply.
I think RAG still give you benefits. One is like, it's not that affordable to fine tune model every day, right? So
Mhm.
if you have up-to-date knowledge, or database that you want to use,
Mhm.
RAG is the kind of the only way to pull that information, integrate it into your AI system, and then answer it. So fine tuning has limitations to do that. And another part is fine tuning is updating the weight. And it is a probabilistic model. I mean, even for a RAG, it is still probabilistic because there's a generation part of it and using the probability to get the final answer. But fine tuning is still like, it's not that it's a one-to-one mapping that I want to ask these questions and get this answer. It's going to answer this exact answer. So to get this factor information and to understand where this answer is coming from, the reg is a lot more helpful than fine tuning. So
Okay.
I think a lot of practical solutions can probably combine both fine tuning and reg solutions together, and also maybe some of the prompt engineering too.
Yeah, I think you can think of it as like, I think when you start, the first step should be like choose what model you want, try different models, try prompt engineering because it's very, very easy. And then if you have a lot of data to use, I think RAG is like the next step to that. And then fine tuning can be a step later on, if you really, really want to get certain like accuracy and efficiency, and you're not seeing that with just RAG. I think like RAG, there are certain use cases where you have to use it, like Rogo, for example, like Heejin was talking about. I don't think their platform would work without RAG. Like you can't like Heejin said, like fine tuning has certain limitations. Fine tuning is more about, showing the model how you want it to respond to certain things and showing it some like good example inputs, outputs. There's only so much you can show it though. Like for something like Rogo, which uses literally millions of documents from like SOC 2 financial reports to like the latest, it's extremely hard to fine tune. I don't even think it makes sense to fine tune a model on those millions of documents. You want to fine tune a model on examples of like, given these documents, given this stuff, here's how I want you to respond, and have it get better at like how to respond. But you're always going to need that RAG pipeline of like, okay, now I need to search through millions of documents of embeddings and find the most relevant stuff for my user's query.
Yeah, and I guess where the data becomes a little bit more dynamic and operational in nature, that makes sense. Yeah. So I want to ask you, with some of the time we have left, to kind of think about the future. I want to get maybe a peek into the roadmap, if you can talk about some things coming down the pipe from Together. But before we go there, what's the future of AI development look like? I mean, RAG is all the rage now. What's the next phase? And maybe we'll go in order. Heejin, if you're comfortable.
Yeah.
I know it's off the cuff.
Yeah. No. I'm very excited about AI. I've been in the AI space for about a decade, and it's been like AI has been always really exciting field, and it's great to see so many more interest and attention and a lot of useful use cases coming up. I think like one of the really exciting part is the multimodalities. So we started with a lot of excitement in the language model case, and I think we'll see a lot more and more applications around the different modalities, not just about image and video, but and audio.
Sorry.
Oh.
I was monitoring the stream of comments in another tab, and it's not came on.
No worries. So like multimodality is a very exciting part, and that will, I think, it may enable a lot of practical use cases as well. Something that we don't focus a lot, but we are seeing a lot from actual like companies building their own application is also related to like documentations and more very detailed modalities, like how do you extract table, how do you extract images, and a lot of documents that company wants to use for their own applications have a mix of all this different kind of data. So using this multimodality and then having an AI is, I think, a very exciting part. And another part that people started to focus more is interactions as well. I studied reinforcement learning in my PhD, and I still love reinforcement learning. I wanted to see more on the kind of the idea of the interactions based AI, not just about kind of one way. So I think there are a lot of interesting discussions and researches going on, and love to see that coming more. And obviously, serving all this model and make development, make it efficient, which what Together is doing, is going to be very important. And we're gonna keep working on to make it more efficient for all these different use cases.
Love that. Hassan, what do you see in the future?
Yeah, I mean, I agree with Heejin. A lot of like the multimodality stuff is super, super interesting. I think I'm just fascinated by how many use cases there are, you know, with just using LLMs. With LLM, like I've seen people do like crazy things with just LLM chaining on like one call, calls another model, calls another model, calls another model. And so I think like AI agents are another really, really big thing right now, and are becoming more and more usable, which is really cool to see. And yeah, I think they can just enable so many cool things. Like I see these startups every day and they just blow my mind. Like like this education startup that will like take in like documents from your class and will build you like a personalized study plan, will build you like a practice quiz, and the practice quiz will be like it'll tell you why you got something wrong. It'll remember that you got it wrong. It'll give you that same answer in a future quiz. And it's just like crazy, the level of like personalization that we can build into these AI apps right now with LLMs. So.
Yeah, I too am so excited by the use cases. I was at I had shoulder surgery, and I was in a medical facility yesterday getting some PT, and ran into somebody who's working on the operational end of trying to cure ALS, and they're looking at AI to take the results of these studies that they do and match that against the profile of all of the people that participated. And it comes down to pretty complex stuff, like the genotype and phenotype of the person involved in the study. Humans can't do this stuff at that scale, but I think about the possibility of like curing some of these diseases as a result of leveraging AI. It's exciting to me. So I'll go back and let's take a look at the future of Together. Heejin, do you want to talk about what's coming down the pipe?
Yeah. There's a lot of exciting projects that are on our roadmap. It's kind of hard to pick, but like if I have to say one thing, one that is really exciting is coming up is like solutions for enterprises. So we are starting to see that enterprises are kind of starting to seeing the similar challenges or the same challenge that we had when we were building this cloud platform. So you have this large customer bases. The traffic can be very variable, like coming from different times and different days, coming from different regions, and you have to kind of the scaled robustly with a stable way and also you can have many different models, and you have to really build your platform to serve them well. So we started noticing that problem, and we are now kind of bringing the solutions to their environments. It can be Together Cloud, or it can be if private cloud or on-prem, but yeah, we're like bringing fine-tuning inference stacks so for their own use cases, and we're really excited about it.
Fantastic. Is there anything else that the developers watching today should know about Together AI?
Hassan, do you want to make a comment?
I mean, I think we pretty much covered it. I think like, you know, as a final CTA, you can sign up on Together.ai, get your API key, start querying your API, and start building really cool apps with Together and Mongo.
Yeah, and there's some links below. You can visit MongoDB.com, sign up for a free Atlas account, check out the capabilities associated with storing your vector embeddings in MongoDB and leveraging vector search. And definitely check out Together.ai. Heejin, Hassan, thank you so much for joining me today. It's been a great discussion.
Thanks so much.
Thanks, Mike.